So my name is Elena Machkasova, and I'm very happy to be here. This is my first Clojure conference. I come from two worlds that are not very common here, probably, academia and rural Midwest. So I work at the University of Minnesota Morris. One possible confusion here is people ask me, so how do your students react to Clojure in introductory class? The answer is, I haven't taught it yet. And I wish I did. And the last sort of 3-ish years of my life was trying to make that wish come true. So I will talk about why I would like to do this, what are possible issues with that. There's a very long to-do list, and I'd be happy to take any suggestions for how to make it possible. So because this thing has been going on for a couple of years now, we actually have a name for this project. It's called Clojure Ed, Clojure in Education. And the goal is to develop an environment that will allow students who have not had any programming experience whatsoever to use Clojure in their introductory class. This is very much work in progress. This picture actually reflects different work in progress, and that's high school robotics that I'm involved in, but this is not the subject, but it illustrates nicely the state of our project right now. So lots of work still needs to be done. A little bit about the background of where we're coming from. You can see that little red dot on the map. We are part of University of Minnesota, but we are 3.5 hours away from the main campus in a town of 5,000 people. We are a small liberal arts college. Small means fewer than 2,000 students. We run a very small computer science program, and if you're thinking small, well, we graduate about 15 to 20 students with computer science major. If you're wondering how many faculty it takes to make that possible, the answer is 3. 3 full-time, and we have sort of on and off, maybe one more person. So we are small. When I interviewed in Morris, that was 12 years ago, I actually had a couple of other offers or potential offers that were closer to what I called home at the time, which was Boston. Very different place. I was a city girl. I didn't know anything about small towns. Made the mistake of ordering stir fry at a local restaurant, because how can one screw up a stir fry? What I knew about Morris was that they do a lot of undergraduate research, and that sounded really cool because I wanted to include undergraduates in my research. That's an excellent idea. But I didn't know a whole ton more, and I asked them a question that I asked everybody, every place that I interviewed in, and that was, what programming language do you use in your introductory classes? And they said, well, you may have not heard of it. It's called Scheme. So it was the most common dialect of Lisp at the time. And at that point, I started listening. And by the end of the interview, I knew that I wanted them to make me an offer, and I would take that offer, and I would have to explain to my 2 kids why we're moving in a town in the middle of cornfields. And it all worked out. 12 years later, I'm still there. So, but I'd like to point out that that question, the answer to that question, was the decisive thing. So a language that we use in an introductory class matters. One thing that you may have noticed is that I don't say which language do you teach in an introductory class. I say what language do you use in an introductory class. So an introductory first computer science class that students are dropped in with no background whatsoever uses a programming language as a tool. not as something that students learn there. So the question is then, what do we teach there? And we teach a lot of concepts and skills that would be useful for their future career in computer science. And we teach computer science style problem solving, meaning you take a problem, you formulate it in a way that could use an algorithmic solution, you implement that solution, you test it, maybe you look back at it and you change things slightly so that when you look at it 2 weeks later, you'll still be able to read it. That would be ideal. So those kinds of things, and there's a lot involved there, but it's not about learning a language. So Matthias Felissen, whose work was mentioned here actually at the talk yesterday, who developed a curriculum called How to Design Programs, defined what a good introductory language is. And it should be simple, have well-defined semantics, sorry, JavaScript, and should be non-distracting. So the focus should be on concepts, on skills, on problem solving, not on learning the language. So some thoughts that Felissen suggested and that I agree with, and some additional thoughts on what that language would be. First of all, I'm a strong believer that it should be dynamically typed, because explicit types are a distraction. That's really not what students should be focusing in. Yes, we do think in terms of types, but we don't always think in terms of types, and statically typed languages tend to introduce typed syntax when it is distracting, when it's not needed. Functional languages are great as first introductory language because they focus on function abstraction. So you write small functions, you combine them, compose them to create your solution. That's modularity, abstraction, all of that good stuff. And one thing that I should mention is that although I've been in Morris for 12 years, and I'm very happy there, the first 6 of those years, I didn't get to teach the introductory class that I was so excited about. And that's OK, because what I saw later on were the benefits from students taking those classes. And you see that in how they use functions, how they use modularity, how they tend to write small Java methods as opposed to one huge thing that students tend to do otherwise. So a couple of extra things to throw in. This is a new benefit of functional languages that came up. Students in my software design class seem to be getting JavaScript callbacks, which is the essence of what happens in web development now. They tend to get it much better if they came through the functional programming introductory class. So that's really important for the modern world. Parallel processing also has callbacks and higher order functions, so MapReduce, all of that good stuff. They may or may not encounter it, but web development, I'm sure they will encounter, for better or for worse. And another benefit of actually not just functional languages, but languages that allow interactive development. REPL is great. Again, forces a lot of testing, interactive testing right away. So these are benefits of many languages, but Lisps definitely fit into that category. Currently, we're using Racket language, which is the descendant of Scheme, and that's, again, the How to Design Programs curriculum. And we're pretty happy with it. But I think there are some things that Clojure can bring to the table that Racket doesn't quite offer. And that is the ability for students to build on what they have learned immediately. I get math majors who try to use programming in doing their math homework because they want to model something. I get students who would like to write an interactive game using stuff that they have learned. And Clojure offers a lot of opportunities for students to use what's developed in the community, interact with people on forums, participate in open source open source projects, attend meetups, well, unless you live in Morris, Minnesota, but all of that good stuff. So thank you very much. That really is something that students can use, all of the work that you guys do. Another great reason to work from Clojure is concurrency and easy access to simple concurrency. You change a map to a P map and you see all of the cores go, and that's an exciting feeling. And if you're doing some sort of processing, statistical processing that requires a lot of processing power where speed matters, then that's a direct benefit. Other things that Clojure brings to the table, integration with Java, that gets helpful later on. I do hope that in classes such as data structures, students would be able to use Clojure in conjunction with Java and kind of integrate that seamlessly rather than using lambdas that were added to Java recently. Another benefit is, and this is my personal opinion, although probably educated personal opinion, is that Clojure has collections that are done right. So if you're doing your own collections, you can use that as a model, and that would be great. So these are reasons why I think Clojure brings additional benefits compared to other Lisps in an introductory class. Now, why I'm not teaching it quite yet? Well, the first bullet point is probably sufficient. Right, okay. That's why we're all here, right? Usability of error messages. So that's definitely something that needs to be improved, and I'll be talking about what we're doing in that direction. Very briefly, other things. IDEs are kind of getting there in terms of being beginner-friendly, but none of them is quite there yet. Beginner students don't really know their way around the project, and it gets really complicated for them to use even a light table, probably. Well, and I tried it not in a class, but with students who didn't know Clojure, and IDEs are still have a way to go for that. Project manager, command line doesn't work for new students. Beginner-friendly graphical libraries, again, things may be getting there, but a lot of work needs to be done there. There is a lot of weirdness with strings that I'm sure you're aware of, but again, throwing it at unsuspecting students is probably difficult. When you apply a map to a vector and you get back a sequence, that makes sense to us. How to work through that with introductory students, I'm not quite sure. I have some ideas. I don't think it's the end of the world, but there are some things that need to be done to at least explain what's happening here in a consistent way. Which brings me to the last bullet point here, which is we need some sort of textbooks that focus on learning, talk about big picture of things, rather than assume that somebody already knows PHP or Java and is just learning Clojure. And that's not quite there yet. So, OK, so now some things that need to be done with error messages, and that's something that we've been working on. We have some ideas, and I'll show you what we have done. So this is an error message, and you can imagine how a new student would be looking at it. It's confusing in many ways. It comes with giant stack trace. I deleted the other 63 or so lines of that. That's a problem. EOF, we kind of know what that means. Students don't. And a lot of error messages, well, all of the error messages are phrased in terms of Java terminology, and we're talking to students who are just learning their first programming language. We can't expect them to learn 2. That's not reasonable. And some of the integration with IDEs, again, it's getting better, but more can be done there. So highlighting where the error happened doesn't necessarily give you the entire information, and ease of navigation to where the error was actually caused could be an improvement. What we currently do, we do some error message transformation. So this is what that error message that you saw will look like for us. So it says it's a compilation error. That's important that it's a compilation error. And it says end of file. And it says probably non-closing parenthesis or bracket. That's a pretty easy guess here. Sometimes guesses are much harder, and I'll talk about that. We do filter stack trace to leave pretty much just the core functions and student code. There are two approaches that we use for transforming error messages, assuming that we have them as Java exceptions. We transform them by applying regular expressions, and we add preconditions to common functions. Now, none of these ways is ideal, but one thing that we really don't want to do is to change anything in Clojure compiler, because somebody would have to maintain that, and that's not going to be us. So we're a small group. We're trying to be very realistic there. OK, so adding preconditions to common functions, I'll talk about that first, what that looks like. So if student code uses a map and they have a string as a second argument and not a function, you see the original message, and that's a class cast exception, Java lang string, and Clojure lang ifn. That speaks to new students and tells them this is a function. No. So what we do here, is we actually tell them that the first argument of map, and we show what that is, must be a function but is a string. So how is this done? We actually redefine map, and we do a check to check that the first argument is a function and the rest of the arguments are seekables. The two functions that you see, check if function, check if seekables, records what the offending argument was. And we only check for the first one, because if the first precondition fails, then we don't go to the next one. And if the preconditions pass, then we just apply the standard Clojure core map to its arguments. That generates a bunch of warnings, because generally you're not supposed to override standard Clojure functions. So we need to deal with that somewhere in our system and just swallow those and not show them to students, because they'll freak out. But that's a minor point. There are bigger issues. So the nice thing about it is that we can determine specific arguments that have caused an error. The downsides of that approach are that we need to overwrite a bunch of functions. And I said map filter. That's how I was thinking initially, and then I realized, oh, it's a plus, and it's less than. It's a bunch of things. We need to somehow load all of that into students' code, because although they probably will know that this is happening, I don't want them to focus on this, this change and think of these as specific functions that they're using. I want them to think that they're programming in real Clojure, as they do. We cannot overwrite all functions. That's impossible. So we do need to have a second approach that I'll be talking about on the next slide. And we need to be careful. So far, we played with that. We didn't see any issues. But the trouble with this approach is once we have overwritten map, we have overwritten it everywhere. So there may be potential issues. We've done a lot of poking around. But of course, that's not a guarantee that nothing will come up. So we're kind of watching out for that. OK, the second approach is regular expression matching. So we have a list of regular expressions for all possible exceptions that we know might happen. That's a lot. It's not an exhaustive list at this point, but we're expanding it. And there, we just match a regular expression, and we rewrite types, definitely, and sometimes the wording of the message. In this case, the wording is fine, or at least we could come up with a better one. And we just replace the types, so sequence and number. The new idea that we've been playing with for the last, well, maybe half of a semester, using what we call user scenarios. So imagine yourself as a new student who is trying to program this stuff, and try to see what possible errors that person might make. This is much harder than you'd think, because it's very difficult to pretend that you don't know something that you actually do know. But right now, we don't have an interactive system that we can use on real students. And we're also looking into an idea of adding what we call hints, so suggestions for what could have gone wrong, and maybe sample code snippets, and see if students can figure out what's going on there. And we're thinking about maybe adding keywords for those, so saying, if you're using a map, that's what your error may have been caused by. Again, this is just an idea. We actually saw a paper that shows that this sort of thing did not work for one group that was trying to apply it to Java. That's not an indication that it's not going to work for us, but this is still work in progress. And the rest of my slides are pretty much work in progress, as in this is the stuff that we're just approaching. We haven't done it yet. We don't want to do it in the wrong way. We're trying to figure out how to do it right. That's been taking longer than I thought. So again, just as we don't want to rewrite Clojure compiler, we also don't want to rewrite, at least to a significant degree, any of the IDEs. We do currently use Leiningen as our project manager. We do need to use it because we need to dump all of the overwritten functions and some additional libraries into student code. So that's going to be there. We want to make sure that we can process errors from student code, run as a file, REPL, testing. We use expectations, great library. So all of that stuff, and we want to use it consistently. So our naive idea 2 years ago was to just put try-catch around student code. Well, that doesn't work in REPL. That doesn't work in any of these concepts. So it doesn't work with lazy sequences either. So we also would like to integrate some of our stuff with the IDE because, as I said, we can't use command line, or we can't have students use command line. So currently, we're looking into using nREPL middleware. We sort of discovered this on our own, and then everybody started telling us, oh, you need to use nREPL middleware. Where were you guys before? But OK. So now we know that that's what we need to do. It's nice to have it confirmed by people who know what they're talking about. So we're working on it. We also need Leiningen plugin, as I said, because we want to integrate student code with our stuff. So it has to be a project. So when they start a file, they actually are starting a new project. And then we want to integrate this with IDE to do a little bit more of highlighting, possibly incorporate hints. Currently, we don't know what IDE we will be using, and actually we would like to stay reasonably IDE independent. So I don't know what people will be using 5 years down the road, light table or night code, or both, or neither. So trying to be flexible there is a goal. Again, so that our students can use these IDEs, whatever IDEs there are, and maybe use something that they prefer. Not everybody will be using the same one, and that's fine. We do need to add project management into IDE menus so that students can start a new file, which means a new project, and have all of the stuff integrated in it, save it in a reasonable way, and all of that good stuff. Okay, so that was already sort of a to-do list. The technical setup is all of that stuff that I showed in the previous 2 slides. And until we do that, we can't really test it on real students, because right now we have a little pop-up with an error message, and it's fine for us, but it's not going to be good for students. And we need to run code separately depending on whether we're catching runtime errors or compilation errors, so that's another issue. So once we have a system that's reasonably usable, at that point we can have students play with it, and then we can do things such as fine-tune the wording of error messages. I understand that many of them are our guesses, and sometimes I know this is probably not the right guess, but I don't know what will work. And hence, all of that stuff actually would be very much interactive process of we give it to people to try, do usability study, record their feedback, talk to them to see what would have been useful here, see their path, how they arrive at a solution, and what would be helpful for them, and work from there. And then, of course, we need to eventually, hopefully, end up with a textbook, but for now, start with a series of lecture notes to help guide students through this process, because there are a lot of things that we need to explain at that level from what they already know, and guide them through that, including the difference between collections and sequences, and all of that good stuff. So nail a lot of things that require very specific explanations for new students. Okay, there are many people who participated in this project. Brian Goslinger was a UMM student, graduated in 2010, who first mentioned Clojure to us. I actually taught an upper level class using Clojure on parallel processing, and Brian technically was in that class and practically was co-teaching it with me. So that was really cool. Stephen Adams, who is currently working on his PhD on not entirely unrelated subject, but not using Clojure, at University of Kent. And he was a big push behind that project in the beginning, so he really thought this was an excellent idea and was very encouraging, and contributed a lot of time at earlier stages of the project. And Joe Einertson, also another student who graduated, and actually is currently working at a startup in Twin Cities that uses Clojure. So that's really cool. And he did the first implementation, and then we work from there. And then a group of students who are working with me on this project in the last couple of years have been working with me. And many thanks to my colleagues and friends for many email exchanges on this subject. And both Minnesota Clojure Group and Boston Clojure Meetup were really helpful, providing ideas and all of that. Okay, we do have our code on GitHub. I have some of the related papers, student papers, on my webpage, so you can find all of this. And really, I kind of would like to have a discussion here about what. Okay, yeah. Any suggestions?
Are you familiar with the work of Andreas Stefik? Stefik is a professor at University of Nevada, Las Vegas. He does
right.
research on language design using statistical data gathering techniques, and basically using science to design languages based on the ability for the different components of understandability and ease of use for using in a learning setting.
Yes, I'm somewhat familiar with his work. He actually overlapped paths with Morris a long time ago, and then I was looking up his name because of his work on visually disabled users, because somebody asked that question, and came across some of the new stuff that he has done. I looked over it probably should look more into it. But yes, the name is familiar, and
Highly recommended.
Okay, sounds good. Thank you.
Have you had any interaction with the community developing the Clojure Bridge material? They're trying to make material that is presentable for beginners as well.
Right. I have participated in Clojure Bridge in March this year. Minnesota Clojure Bridge, it's a very active organization. I will be helping out teaching one of their tracks in June. And one of the things about what we do, what Clojure Bridge does, I think it's important, again, to focus on learning goals, and I'm not sure if they're exactly the same. And the background of students, again, if most students have absolutely no background or they have background in different programming languages. And these two things are totally different. In Minnesota, we don't get a lot of students who have any programming background, although if they do, that, and there is a percentage of them there, that creates a very interesting sort of difference in the classroom where people have done a little bit of PHP and they think they know it all. That moment when they ask me, so I understand about define and all that, and they ask me, so how do I change a variable here? And I say, you don't. And they look at me, there is that moment of, they just can't believe that I'm saying that. What do you mean you don't? And I say, no, in Racket, you don't. It's a functional language. And that after I talk about parallel processing and why immutable data is useful here and all of that stuff, yeah, it's an interesting moment in the classroom. It's a teaching moment. Yeah?
So you were saying one benefit of Clojure over Racket is that it's something you can really continue to use as you move on. But it concerns me that fixing the error messages will make that harder for students later if those changes don't make it back upstream. Have you looked into trying to make those changes in a way that could be pushed up as patches into the main compiler?
Right. Well, nothing prevents students from actually continuing using our error messages. Hopefully, we can handle things in a fairly general way. At some point, probably Java stack trace becomes useful. We don't hide it, actually. You can still see it. So you can still see the original error messages. And that may be a nice transition point. Yeah. So we filter it and we show them a user-friendly one. But you can also go into the original one and see stack trace in its entirety. And maybe that's a good way of approaching it. When they start doing that because they need it and that's helpful, that will allow them to transition to general tools. I don't see why it can't be a mode of, say, light table or night code to use beginner-friendly messages.
Actually, I mean, just push it up into Clojure and give us all those friendly messages.
Sure, yeah, and again, I'm not exactly sure to which degree of beginner friendliness we want to go. Racket has messages that, for good reasons, are not very precise. So again, for real developers. But they also have a system of languages, beginner languages that's stratified. So you start off with, for example, a system with no higher order functions. And then you eventually get to the next level where you can pass functions to functions. But it doesn't, unfortunately, get to full-scale Racket. And that's a pity, because I've been working with students who really would like to start bringing in all of the Racket libraries, but you can't do it at the level of student languages.
So how long is this course?
A semester.
A semester.
Yeah, a semester course. The next programming course that they take would be data structures in Java.
So as you just pointed out, the How to Design Programs curriculum very intentionally shows students only a tiny subset of the Racket language. And if you're going to follow that sort of curriculum with a Clojure language, you'd still presumably only show them a tiny subset of it. And with that in mind, I'm thinking Racket is known as sort of a state-of-the-art platform for creating new languages on top of it. It seems like it would be easier to make in Racket something that acts Clojure-ish so that they can move on to full Clojure if they want, but you maintain that kind of functionality and sandboxing and the graphical REPL and all the things that have already been built with the Racket infrastructure than it is to try to turn Clojure into something that's that accessible to beginners.
It's an interesting point. I find, it's on record, right? I find Racket a little bit verbose. So, and I'm not sure what's easier, really. But hash maps are fantastic, and Racket does not support them. I understand that
build that stuff.
You could, yes, you could. Yeah.
Like a Clojure version beginner student language.
You could. And that's not the direction we're going in now. Alex?
I just want to mention that in terms of moving things up into Clojure, there's one of the main reasons why we haven't done more with preconditions and things like that inside Clojure is because there is a performance impact to that, and that you're checking the type of every argument for every function call. It has a really significant impact. However, we have this new feature called reader conditionals. It allows you to conditionally put things into your code, and it would be entirely feasible at this point to change the build process to actually build a version of Clojure that had preconditions in it and a version of Clojure that did not have preconditions in it. And you could choose to use the one that had the preconditions in it. And so this is something that I'm really interested in. I'm hoping that we will be able to move forward with that idea this year. And so there might be like a Clojure that has a classifier on it that's like, Clojure friendly or something. It's going to be a dev-related form of Clojure. And I think that's very feasible. We already have.
Yes, I think using reader conditionals would be fantastic. I saw that last night, and I was very excited about that.
Separately,
Yeah.
I think there are error messages that could be better.
Sure. Well, and it's an interesting question of whether there is such a thing as beginner-friendly specific error messages or just making error messages better for everybody else, and if that's the same thing or not. And I don't know right now. I guess my goal is to kind of get this thing, given that it's been already close to 3 years, to actually try it in the classroom with sort of the minimum setup possible, see what we learn, and maybe bring that back to Clojure community. But I'm a little pragmatic right now because I was hoping to teach it, in the fall after the year when I started looking at it first. I was on sabbatical, and I thought I'll put a couple of months into that. Yeah, that was 3 years ago or so.
Sorry, I'm just trying to throw out an idea here. You could make it a game where students given a REPL write some code, they get a horrible stack trace, they figure out what the problem was, and then there's sort of like a wiki where it maps a fingerprint to a stack trace to what the problem was. So you could have all the students sort of fill that database in for you.
Well, I just think that incapable of reading a stack trace. I mean, I'm also concerned about the fact that, when we have 40 students in an introductory class, we hope that 25 of them will take data structures in the fall. And if that's not happening, my colleagues are not going to be happy, neither will I be. So,
Code does blow up all the time. We do the same thing. We get a stack trace, we throw it into Stack Overflow or Google, and we're like, what the
Yeah.
heck is this, dude?
Yeah, and it would be great at sort of higher levels, but beginners they don't have the capacity of doing that.
Right. So once this wiki has been put into place, then the next students that hit that problem will see the nice version.
I think you're exaggerating a little bit of how much time an average student is willing to put in before they, give up and do something else. And that's my concern. And the side note on that is that we also would like to increase diversity. And sometimes students feel that they're coming from less exposed background anyway, and everybody else knows what they're doing, and everybody else just sort of says that they know what they're doing, but that doesn't matter. And I think beginner friendliness helps students who already feel a little out of place for various reasons. And I want to make sure that we're supporting these students. So, okay, I think we need to wrap up, but thank you very much.